if we have a function, logarithmic function to graph, let's just do log base 2 of x to start with here. And I want to graph it. Well, start with the table, okay? All right, so we're going to pick x values, and then the y values, of course, will be the logarithm base 2 of x that. All right. Well, first of all, what x's are we going to pick here? We have to be kind of restrictive here, don't we? Because we've already said that if we're just dealing with log base 2 of just x, x can't be a negative number or 0. And so the x values here, I'm not going to have any negative numbers or 0. Those are not going to work here because x can't be 0 and it can't be negative, right? So let's just start with 1. 1 and 2. All right, so that's log base 2 of 1 would be the y value, right? What do you got there? Log base 2 of 1. What value does that have? So I might have to do a little thinking here. The value of that's going to be 2 to what power is 1, right? Which again, to get a power of 2 to equal 1, what do you got to go with?
0.
That's 0. All right, so that one's 0. We got 2 for x. It'd be log base 2 of 2. What is that going to be? 1. 2 to what power gives me 2? Yeah, that's 1. That's 1. Now, brings up the next point, all right? Since basically what I'm dealing with are powers of 2. 3 right now anyway, we'll talk about how we can get it later on, but 3 is not going to do me a whole lot of good because it's not a nice power of 2. You see what I'm saying? So my x's here, for this purpose here, the x's here, let's just go with powers of 2. Make the x's powers of 2. Powers of 2. And so the next power of 2, let's go with 4. Because that's a power of 2. So that'd be log base 2 of 4. And so that's my next power, right? So that's the next power of 2. So that value is 2, okay? What would be the next nice one then?
8.
8's a nice power of 2. The next power of 2, matter of fact. And it's, of course, 2 to the what power is 8. That'd be 3, isn't it? So that's where we get the 3. All right, so let's get that going here. All right, so nothing, no x is 0, no x is negative. We got x is 1 is 0. X is 2 is 1. X is 4 is 2. Y is 2. Right here, right? 4, 2. And then we got 8, all the way out to 8 to get to 3. Y is 3. So yeah, you can tell there that one's, unlike the exponentials where the increasing ones, they were going up, and most of our polynomial functions, they were going to infinity over here on the right side, but not so with the logarithms. The logarithms are just kind of gradually going up. There isn't a horizontal asymptote. It does continue up on up, so it is increasing there without leveling off, I guess we would say. So it is increasing. Now, there is a little piece though that we need to talk about here between 0 and 1. Between 0 and 1, let's think about these values. 1/2 1/4, 1/8 for x. X is a half, x is a fourth, x is an eighth. What have I got for the y values there? Well, it's log base 2 of a half. Well, that's 2 to what power gives me a half? Well, 2 to the first gives me 2, but to get a half, it needs to be -1. And similarly, when we get, for log base 2 of a fourth, a -2, and then log base 2 of an eighth would be -3, because 2 to the third gives me 8, and then to get 1/8, it needs to be -3. Follow me there? Well, I show you those because here's what's happening. At a half, x is a half, I've got -1. At a fourth, so halfway between a half and a 0, at a fourth, I've got -2. And then in an eighth, which is halfway between a fourth and a 0, I've got -3. Does that remind you of anything, what's happening there? I'm getting closer and closer to the y-axis, but it's a vertical asymptote. Yep. There's a vertical asymptote of x equals 0. Yeah. Yeah, in logarithms, you've got a vertical asymptote. The exponential functions, you have a horizontal asymptote. Logarithmic functions, you got a vertical asymptote. And so that's the basic shape. Remember exponentials, we described those as hockey sticks. Well, it's the hockey stick kind of turned over, isn't it? You know, the exponentials that did this. This one's kind of going a little different, different way there. Is that okay? So the basic shape of logarithms, that's what it looks like. In general, if you got y equals log base a of x, a greater than 1, let's say, you got that. General shape is that, where you have a vertical asymptote at x equals 0. Crosses, you know, x-intercept of 1 there. And that's the basic shape. Do some shifting on it. Maybe we'll do one of those. But now the good ones that we can do, because we can get all kinds of values, would be what does this one look like? Y equals ln of x. Well, because we have the ln button on our calculator, we can do all sorts of x values here, just not negatives or positives, but we can do 1, we can do 2. Yeah, we can do whatever value because those we can just punch in on our calculator. That's of course 0. ln of 2 though, ln of 0.693. ln of 3 is much bigger than that, but it's a little bit, 1.0, say 1.1. ln 4, 1.4, ln 5, yeah, we just get whatever value you want there, 1.6, so it's not going anywhere fast, but with just those values, we got a pretty good idea. Points, so ln of 1 is 0, 2 is 0.693, 7, 3 is 1.1, 4 is 1.4, 5 is 1.6, so yeah, you got that. So it doesn't give me a whole lot, but knowing that this is the basic shape, fill in the rest, all right? So it's going to continue out like that. What's it going to do here? Vertical asymptote, x equals 0, same basic shape. Same basic shape. Yeah, it may ask you about domain and range on these. We haven't talked about those a day or two. What would be the domain here? What does the domain pertain to?
Oh, the x value.
The x value, all right.
Zero
So the domain's the x's.
Or it'd be above 0 to infinity.
Yeah. X, we know the restriction on the logarithms is x can't be 0 or negative, so x has to be something greater than 0, doesn't it? Or 0 to infinity. Yeah. 0 to infinity. The range is the y's, the y values. What y values am I getting here? Is there any restriction on that?
No.
I get negative y values. And like I said, this doesn't ever level off. It keeps going up and up and up. It's going to take a while, but you're going to get to 10 and to 100 and to 1,000. You'll get those y values. So what's the range?
Negative infinity. To
all real numbers, yeah. Yeah, so logarithms, the basic ones, do this. All right, let me show you one other thing, then we'll be done with it today anyway. F of x equals the log base 2 of x minus 3. What do you see happening there? We got some shifting, don't we? There's some shifting going on here. What kind of shifting would be going on? The 3 is on the inside, and it's a minus 3. So it goes left or right. Minus goes to the right. Yeah. So this is going to shift it 3 to the right. Well, in particular, what feature gets shifted 3 units to the right? That vertical asymptote, doesn't it?
Yep.
So if everything gets shifted 3 to the right, our vertical asymptote now is shifted 3 units to the right. So the vertical asymptote now is at 3. Yeah. Yeah, so the vertical asymptote gets shifted over 3 units and puts it there, which kind of gives me an idea if I was wanting to put a table together here, knowing that, what values would I want to pick? Well, since everything's shifted over, now that shifted the restrictions on x too, because the vertical asymptote is kind of the boundary, isn't it? I'm not going to get anything over here as far as the x's go. It's all going to be over there. So I probably want to start at 4 and then come up with some other values that would, you see what I'm saying there? So that's important to note that everything's been shifted to the right. And so that shifted points that I would want to find. But plug in the x is 4 and you got the same old thing on here. You got log base 2 of 1, which that's 0. If you do 5, you got log base 2 of 5 minus 3. It's log base 2 of 2, which is 1. If you go with 6, you have a little bit of a, I mean, that's a number. Let's just say it's not a nice number. Okay, quote unquote. There's not a nice power of 2 that gives you 3, so 7 would be another one. I believe that would give me the log base 2 of 4. That's 2. So that gives me a pretty good idea. At 4 you're at 0, at 5 you're at 1, and then at 7 I'm at 2. So there's that. And then our vertical asymptote. So anyway, just in case you have to draw one shifted like that. Any questions on that? Look okay?